Hello. So this video is going to be a bit of an introduction to the Houdini engine in Godot GD extension that I released yesterday. You can find it on GitHub. Um, the link will be in the description. But basically, in this video, I want to give a bit of an overview of what the current status of it is, what features work, and give a bit of an idea of how to use it. I'll also go over like installing it and all that stuff. And I'll also talk a bit about the philosophy behind it and, well, why I made things the way I made them, basically. To give a bit of a background, I am a procedural tech artist in the games industry. Um, and I've used Houdini Engine in proprietary engines, Unreal, Unity, for quite a couple of years. And basically, I was dabbling in Godot and I was learning C++. And I thought, why not combine the two and make Houdini Engine in Godot? Um, so that also means you'll probably find horrible code. Um, but I do think I came quite far, and you can already make quite cool stuff. These examples probably don't look all that impressive, but honestly, that is mostly due to me not having time to build fancy examples. I'm more focusing on the Houdini Engine integration itself. So the HDAs here are like super simple, and you could probably make like much cooler generators already with the current feature set it has. Um, One thing I will say right away is that this only works with FX and core licenses, well, and the commercial Houdini Engine licenses right now. It doesn't work with Indie, sadly. So if you don't have an FX or core license, well, that's not gonna work, unfortunately. Um, but yeah, so I will show these couple examples I have in this demo file here. Um, you can download this demo file as well, so that is also contained in this repository. It's this demo folder, so if you just download it and open this folder as a project, you have it. However, you do need the OTLs as well and add them to your Houdini path. So they can just be in your like documents Houdini 20.5/OTLs folder. Um, and then stuff should work. Um, I'll go over like installing it in a fresh project and how to use it and all that a bit later in the video. But to show the feature set right now, basically you can, well, send geometry to Houdini, you can retrieve geometry from Houdini, you can send splines to Houdini, you can set parameters, and yeah, you can also retrieve points for instancing. Um, and one big difference to the default Houdini Engine integrations in Unity and Unreal is that I'm taking an approach where I'm first of all making an API that is accessible to GDScript. So I'm not right now at least making like a fancy UI version that like reads an HDA automatically and then generates a UI for it, sets up the inputs, and then handles the output for you. That is not the main goal of this integration. I want to have maximum control over how data comes to Houdini and how data is read from Houdini and what to do with it to the tech artist making the tool or artist or whatever, right? Like whatever you want to call yourself, the Houdini user, right? So um, how that looks basically is that Houdini nodes are represented as classes in GDScript here. So you have a Hego asset node, which represents an HDA in Houdini. So you use that to instantiate your HDA in the Houdini engine session. You use it to connect inputs. You use it to fetch outputs. You have a Hego input node object or class, which represents an input node in Houdini. So you can use it to send a mesh over and then connect this to the HDA. Or you can send over a curve by using the Hego curve input node, or you can merge multiple um, nodes together with uh, a Hego merge node. Basically, the idea is that you're kind of familiar probably with how Houdini Engine works under the hood in Unreal or Unity, anyways, right? Um, because you can look at it in session sync. And well, if you've ever done that, you've probably seen how it works, sort of. And the idea here is that I'm exposing all of this to you. Um, so you write a script that handles all of this conveniently packaged in these classes. So I will go over this a bit. So first of all, I will show a couple of examples and how they work. So you can see here, I can move a spline point, and then so this is the regular path 3D, the regular Godot path, and then I can hit recook, and it recooks. It's floating there a bit. So I'll quickly fix that. Nice. So this is like a really simple fence generator. The output is just stored as a mesh, and then I'm just reading this mesh and outputting it here to or like assigning it here to this mesh instance. Um, then I have this multi-mesh or like this test scatter which spawns this grass here. Um, so if I delete this output and hit recook, you can see this works quite nicely. So we quickly get our grass back from Houdini. And then I have this picket here, which oh, why will it not let me select it? Oh, I'm not in select mode. Okay, now. I'll quickly delete it and recook it. And this doesn't look like much right now, but I don't know if you can notice. It's a bit exaggerated for the video. It has LODs. So if I put wireframe on, you can see here how it switches between LODs. Let me go back to normal. And yeah, another generator I have here is this sci-fi panel one. So if I hide this one and enable this hello world one, you see that this is like the actual well like the input geometry. It's just like a Godot text mesh. So I can actually let me go in here and find the text if I find it. It's been a while since I looked at this. Uh, yeah. Ah, here's the text. I'm blind. Okay. Um, I'll just change it to hello. The picket is now floating a little bit, but doesn't matter. Um, and now if I select my this node here, you can see it still has the old output. But if I recook this, this one is a bit slow because it's actually quite high poly count. I didn't care about optimizing anything here. Since yeah, it's more to just test the different materials being assigned here. And here we have the output. So if I now hide this hello world, we have our beautiful sci-fi panels. Well, sort of. Um, but yeah, so those are the things that work. And actually now maybe also to show this because the test scatter, it like takes into account the mesh as well. If I recook this now, you can see the grass is now around the hello again. So yeah, that's kind of showcasing a couple of things you can already do right now. And I mean, basically with this, I'm sure you can already imagine that you could do a lot cooler things, right? Like you could make a house generator, you could make like you could generate entire levels with spaceship, like whatever, right? Like basically the HDA is like you can do whatever you want. And I mean, you can get instances, you can get meshes out of it. Terrain right now isn't supported at all yet. That's mostly because Godot doesn't have an official terrain solution. Um, so I decided against it. I know there's like a Terrain 3D plugin that seems to be like the standard. So I might try to look into supporting that in the future. But yeah, for now, no terrains supported. Um, but yeah, to go over this fence example a bit, because this is just the most easy one. So I thought I'd pick this one to kind of showcase how this might work. Um, so here you can see making it a tool script. That's just to make the code actually run in editor. It extends mesh instance 3D. The benefit of this is that I can assign the mesh directly to this node because the mesh instance 3D can render a mesh. Um, However, you could also instead have like an empty curve, an empty node 3D, which or like a child of empty of like a node 3D, and then create a child of that, or like create a mesh instance 3D as a child of the node 3D, and then assign the mesh there. Or you could even create it separate, right? Like there's a lot of ways you could do this. So yeah, but I decided to create it as a mesh instance 3D directly, or child of it, um, and give it a name HDA curve test. And basically, I'm creating the Higo asset node and the Higo curve input node objects in memory here. Um, oh, well, rather the variables without any values assigned yet. And then I have this hacker recook button. This is just because I'm in 4.2.2 stable, which doesn't have buttons yet. I know in a newer version of Godot there is buttons, but for now I decided to stick to this version because it should be forward compatible, but GD extensions are not backwards compatible. Um, and so I only want to update when it's actually necessary, or if I get some benefit that is more than just getting a button. Um, but basically, this just makes it so I can hit a toggle and it cooks or like calls this function. And then I have another export variable for the input node. So this takes the spline. So here I'm exposing it as a node. You could also make this path 3D, would work the same way, and probably be cleaner. And yeah, then in the cook function, basically I'm just making sure I actually have a valid Higo asset node object in memory. Um, I'm doing it this way because if you or like I'm storing it in a variable and then doing it here like this, so that I can recook without creating new nodes over and over again. So that is going to be very important when you make these scripts. Um, and then I'm assigning the operator. So that's this asset name here. Basically, SOP just means it's a SOP. So right now, I mean, I didn't test any other operators, so no guarantees that any others will work. And then this Higo curve test. So that just has to be in your Houdini path somewhere. Doesn't have to be imported. And then I'm instantiating it. So basically, this function, what this does is it just creates the node on the Houdini side. I'm then setting the transform to the global transform. Usually, that's probably what you want to do. Basically, just gives the object level. Basically, it just gives the node an object level transform in Houdini that matches the object level transform in Godot, or like whatever transform you feed it here. Um, that is so that it's like relative to the inputs as well, right? Um, and then yeah, same thing with the Hego curve input node. So yeah, this node is responsible for taking the curve input. So I'm also instantiating this. Basically any type of node or Hego node that you create, you have to instantiate. And then you do stuff with it. And yeah, then set curve from path 3D. So you just feed it a path 3D node and then the sampling distance. So 2 means a point every 2 meters, 1 means a point every 1 meter, etc. Um, and then on the asset node, I'm calling connect input and connecting the Hego curve input node. Um, and this just hooks it up to the first input here. So that's why there's a 0. So if you want to put something on this first in or like on the second input, you put a 1. Um, Now this probably needs a bit more explanation. So there is this fetch surfaces config, and I'm loading that here, and then I'm using it in the fetch surfaces function um, as an argument. And basically, this config defines what attributes I'm reading, what attributes I'm splitting by, etc. I'll go over it a bit in a moment. But basically, I'm then just creating a new array mesh in memory, and I'm calling add surface from array. So this is like default Godot behavior, and feeding it the surface array that I'm getting out of this fetch surfaces function. Then I'm assigning this to the self.mesh variable. So that again was the benefit of using a child of mesh instance 3D, because then I can just set the mesh directly. And so I don't have any like weird temp geometry or anything. I just have a mesh instance 3D node with a script on it, can hit recook, and the mesh is assigned here. So I feel like that's really cool in terms of handling the data in whatever way you want and having control. In the future, I will make a UI that, but yeah, right now, um, I don't have that yet. Um, right. So, I will quickly talk a bit about the configs. But to be honest, I think you should probably play with them a bit to sort of understand what they do and like maybe print the output depending on when you like change the configs and then print the dictionary that is returned, and then you'll see how it works. But to go over it a bit, basically in this Higo add-ons, Higo, you have these, well, I mean, there's the definitions here for what they are, and then here's like the default values. So basically, this defines how data is read from Houdini. So on the point config, you have only loose points as a toggle. Basically, if you toggle it on, it means it'll only grab points which are not part of any sort of primitive or mesh. So yeah, only loose points. Read attributes. Basically, it's just a list of attributes you want to read. So in this case, there's n, cd, up, and p scale. P, so the position is always read. So you don't need to add that anywhere. And then you have filter attributes. Right now that's completely empty, but basically you have filter attributes and filter attribute values. And how that works is in here, you would add an element and then say, maybe I would want to only have points where, I don't know, Hego instance is 1. So I would go here, add element, and then here you can change the type to an int and say 1. And now this would only return points where the Hego instance attribute is 1. Now I don't have any example with that, so I am quickly going to remove this. And then split attributes is the big one. That is probably going to be the most confusing. So this basically works in a recursive manner where the list of attributes you feed this is going to be used to split the instances by. So how this might work is, let's say you want to have multiple different meshes you instance. And maybe you want to spawn multiple multi-mesh instance objects in like a grid pattern to partition your output for performance reasons, as one multi-mesh instance is always either fully drawn or not drawn, and all instances of it always use the same melody. So if you say wanted to generate a huge forest or something, um, you would want to partition that in multiple multi-mesh instance objects. And you could achieve that with the split attributes. So maybe you would first want to split by an attribute, like I'll actually write this in here. So maybe you would want to split it by first Hego tile. and then maybe by Hego inst or something, right? So that you would get like a grid of the tile to create a multi-mesh instance in each tile, and then also split by the instance itself. So you could create one per different instance. So you could spawn, I don't know, let's say a pine tree, ferns, grass, and a bush or something, right? So you would get 4 multi-mesh instances per tile to spawn those 4 different meshes. And you can like probably think of a lot more complex use cases for this, right? But this works in a recursive manner. So you could basically the return is a dictionary where the values of the attributes are the keys. So if you had actually I have this somewhere in the documentation. Let me quickly pull that up. Right here. So yeah, as an example, if there are Higo tile or Higo and Higo mesh, you might get something like this, where like first you have 0, 0, and then in 0, 0, you have an entry for test grass, which contains these 2 points, and an entry for cactus, which has these 2 points. And then in the next tile, again, you have different positions for test grass and test cactus. So basically, you can iterate through this dictionary and then spawn the things yourself um, according to the data you receive out of Houdini. Um, so that's the basic idea of it. And then for the surfaces, it's similar, but a bit more. Well, actually, not really more complex, but yeah, basically, you have the normal, the color, UV, UV2. You have read attributes where yeah, you can just read primitive attributes. Filter attributes, again, same thing. So that filters by primitive attributes. And then you have the split attributes. And I actually have 2 examples of these split attributes here. So in this Higo folder here, I have surface configs. And I have one that splits by material, so you can see there's Higo material, and here I have one that splits by Higo lot, which splits by Higo lot. And then in the which one is it? This one. Here, this is actually used. So this might look a bit intimidating, but I will go over this, and I think it's gonna make sense. So here we have again child of mesh instance 3D. It's the HDA sci-fi panel generator. Stop is defined here. And then, yeah, again, the Hacky Recook button. And then I have an export of an array of mesh instance 3D. So in this case, I didn't want to just be able to select one mesh. I wanted to be able to select multiple. Then again, same thing. I'm creating the Higo asset node variable, Higo merge node variable. And then in this case, I'm creating an array of Higo input nodes as a variable. And this is again to support feeding multiple. And we need to be able to keep track of all of them. Otherwise, we're going to keep creating duplicates over and over again when we recook. And then in this cook function here, basically I have, well, same old thing. So first of all, checking I have a valid Higo asset node object in memory, and if not, I'm creating it. Assigning the asset name, instantiating, setting the transform. So that's all the same as in the fence example. Then I make sure I have a valid merge node object and instantiating it. And then basically here I make sure that if I have like if the user ends up deleting um a deleting an input, I'm making the Higo input nodes array smaller as well, or like resizing it to the correct size. Um, and then I'm iterating over the input nodes, and if it's bigger, or if there's less Higo input nodes than there is um, input nodes, I'm creating a new input node. Um, and then, well, I'm instantiating it, and I am setting geo from mesh instance 3D. You don't have to worry about this instantiate being called again. The instantiate makes sure that it doesn't basically internally it tracks a node ID, and if it already exists, it won't instantiate again. It just has to be the same object in memory for that to work. So that's why this is there. And then basically I'm connecting the inputs. So on the merge node, it has a function connect inputs, and it accepts an array of uh, Higo input nodes. Or to be honest, like any sort of Higo nodes. So you could even like merge multiple HDA outputs together or whatever. Like you're not limited to only spawning one HDA. You could chain them together or do all sorts of crazy stuff dynamically, even based on parameters. Um, and then I'm connecting this merge node to the Higo asset node. And that way you can connect multiple inputs into one input. But so to get to the interesting thing here with the split by material, so when I do fetch surfaces using this config, so this fetch surface is split by mat config, what I'm getting is a surface, a dictionary that is split by the material. So you can see here, I also load my materials, and then I'm going through the dictionary, and I'm looking for main, dark gray, accent, dark accent, black, default, and assigning the correct material to these surfaces. Now, this is sort of a hacky or like hack together manual way of doing it. What I would recommend is to actually, instead of just using a name here for the material, I would use the actual path. So assign this to the attribute, and then do this in like an actual loop where you load the material based on the actual value and then assign it. That would be a lot smarter and more adaptable if you want to like later add more materials, etc. But so this is one example. Um, and there is also the LOD one is probably a bit more complex. I will try to explain it, but don't worry if it doesn't make sense to you. Because this one does require quite a bit of understanding of Godot array meshes. Um, so same thing up here everywhere. I'm just tracking the asset node here because there's no inputs. Making sure it exists, setting transform, instantiating it, etc. And then I'm loading the split by lot TRS. So after I fetch surfaces, basically what that means, I now have it split in this dictionary according to the Higo lot attribute. And the Higo lot attribute in this case is just a float that like goes from 0 to I think 1. I don't know if there's a limit, to be honest. But it's like a relative value that's like 0 is close, 1 is far away, basically. And then you can bias it with some values on the node itself. But basically here I'm creating an array mesh and an empty surface array, and I'm setting it to null everywhere. So the surface array is like check the Godot documentation about it if you're not sure. But basically it's an array of 12 more arrays that contain point positions, indices, normals, UVs, all that sort of information. Now, the annoying thing with the LODs is to set up LODs, you need to have all of the vertices of all LODs in the vertex array. So that's like the entry 0, I think, of the surface array is the vertices, so the positions of the points, basically. Um, and we need to combine all of those. And then how the mesh is assembled is like there's the 12th index or like the 12th entry of the surface array is an array that contains the like 3 indices always making up a pyramid or like a triangle, um, that are in the positions array. I'm hoping I'm making sense here. The Godot documentation probably explains the basics of how this works a lot better. But the annoying thing with the LODs is basically you need to merge. So we have them split now, right? So they're split by this attribute, um, and we want to put them all into like all the positions need to be merged into one surface array, but then the indices need to be offset because we're merging them together for the LODs to work. Because the LODs array or dictionary, so how this works is the add surface from array, it takes this LODs dictionary, and the dictionary, what it expects is the values from 0 to 1, um, and then an index array as a value that contains the LOD for that. But the points need to be in the surface array, so in this surface array here. So that's why this setup is a bit more complicated. Basically, I am looping over the keys, so the values for the LOD. So the values might be 0, 0.5, and 1 as an example. And then I am loading the surface array. I am adding, like, if it's the first one, I'm just assigning the first value, so that's LOD 0. I'm just assigning that to the surface array, and if it's not, I am adding it to it, and I am, basically changing the index offset by this size. And that is to make sure that um, the LOD array actually works afterwards. Really complicated, probably sounds horrible. I will definitely make a function that will automate this process here, so like all of this math stuff, um, for you. But for now, that's how it works if you want to integrate LODs. Um, and yeah, then I'm just assigning it. But so that's kind of the gist of what you can achieve with these configs. And yeah, I mean, the really cool thing, in my opinion, is that you can read any attribute you want. Like, I'm not limiting you at all. Um, in terms of that. The only exception is I'm not supporting vertex attributes at all. Um, and that is because I like basically Godot doesn't have an understanding of points in Houdini, right? Like a point in Houdini is like consists of multiple vertices, and Godot doesn't care about any of that. Godot just wants like just considers positions and then primitives, normals, all of that. Um, and so I decided to not support vertex attributes at all, just to keep things simple. So that is one limitation. I also decided not to support groups. Um, that is because groups are kind of just integer. I know that's probably not correct, but in terms of what they represent, you can do everything you can do with groups, you can do with an integer attribute. And I just want to keep things really simple and consistent. Another limitation is I'm not supporting pack geometry, and that is because there is a lot of confusion about inherently, I feel like, with pack geometry and Houdini Engine in terms of like, does this attribute affect it if it's like packed inside, or does it need to be outside applied to the packed primitives, right? Like all of those kind of confusing things. I'm sure if you've worked with packed primitives in Unreal, you probably know what I mean by like it's confusing. And so I want to keep things simple but very customizable. And I think this is quite a nice approach to that. So yeah, that should be it for the little intro. So now, yeah, you kind of know what's possible and well, how working with this looks like. I really suggest if you want to make your own scripts that um use this. to check out the documentation. So there's documentation on the asset node. There's also these example scripts. Um, but like I said, I would recommend downloading this demo. So as a last thing, I'm going to, well, show how to install it. Um, that is fairly simple. So you have this first release um, thing here, and you can download the release here. Now I already have it there, so I'm not going to download it again. But basically, um, you just get this bin and add-ons folder, and you can put that into your Godot project, and then you have it installed. Of course, you also need Houdini installed with a valid license. But yeah, so I'm quickly. Oh, actually, I'm going to close this instance. Let me check. I still have my Houdini here. Okay, nice. And I'm going to click new, and I'm going to browse to projects, new folder. Uh, I'll call it test demo. I don't want version control. Create and edit. And yeah, now I'm gonna close it again because now we should have our folder. So I'm going to go to C, projects, test demo, drop that in there. And then I'm going to restart Godot. Actually, also in the meantime, I'm going to use the time to also close my Houdini and reopen it. And then I'm going to load test demo. At first now, I'll bring up the console. It's probably going to print a couple of errors. Yeah, here we go. That for some reason happens the first time you open it. So just close it again, reopen, and now it should work. Actually, I forgot to do one little thing, but that should be fine. So in project settings, under plugins, enable this. Plus. Okay. And now you should have this Higo panel over here where you can start a session. So if my Houdini is started, yes, it is. I'm gonna quickly bring this over like that. I'm going to open the, and you don't need to do this, but I love working with session sync in this way, especially considering like it's an API where you sort of control what happens in Houdini. Yeah, session sync is really nice for that. So yeah, I started the name pipe session here, and if I hit start session, see I get my global nodes here. Um, and yeah, so we have a connection to this live session now, but we don't have anything here yet. So what I am gonna do is I'm gonna say I want a 3D scene, and in this scene I want a mesh instance 3D, and I want a path 3D, and I want. Actually, I'm gonna leave it at that. I'm gonna quickly open the other project because I'm lazy, and I want to copy paste the code. Um, so if I grab this here, so I have the code for the yeah, this is all fine. I'm gonna save this as test scene. Cool. Um, and you're gonna encounter one bug here now. Basically, let me assign the input. So I'll assign the path and quickly select the path and add a couple of points. Okay, yeah. So now you would expect this to work already. However, it does not. That's a Godot bug. I think at least. Basically, it doesn't recognize the update to the script. Um, So the solution to that is to just restart Godot. So I'm gonna do that. Ah, I opened the wrong one. I can close again. Yes, I want test demo. So I'm moving that over, and now go to the scene here. Ah, yeah. So classic rookie mistake. I didn't actually have session started. So start session, recook, and there we have the fence. So yeah, that worked fairly quickly. And just to show also how to change parameters, I'm quickly going to do that. So yeah, here we have like maybe just to show you a bit what happens under the hood is like here we have the null node, which like basically this is what is represented by the Higo input node, or in this case the Higo curve input node. And then this is the Higo asset node, and this is what is caused by or like how it's connected when you call the connect input function. But maybe we want to expose a height here, right? So I will go to type properties. I will say parameters, and I will add a float, and I will give it a range of like, let's say 0.8 to 0.5 meters, maybe. Maybe that seems reasonable. Channels, I'll say default value 1.2, maybe. Oh, 1.2. Hit accept. And oh yeah, maybe also just to be clean, I'll add it as a name and label as well. I will copy parameter, and then I am sure somewhere here. Where does that actually happen? Um, right here, I'm adding them. Okay, yeah. So, paste relative references. Okay, now I have the height here exposed. And I guess these values you could also expose, but I'm just gonna do this for now, just to showcase that you can change it. So now I do save node type. And in the script here, I am now going to maybe make this full screen for now. I'm going to export height mode equals 1.2. And then here I'm just gonna say here you go asset node called set palm, and I called it height, and I will feed height. Now I save this. Here we go. And now I can configure this height. Oh, why did it not? Okay, it does store the value. Okay, so maybe just to make it super obvious, I'll set it to 3, hit recook, and we don't see anything. Okay, so I figured it out. Um, I need to match definition. So apparently this does not like it if you change the HDA and then don't match definition, but now it works for some reason. Not entirely sure what that is, but so yeah, just make sure you match definition. And now you can see I can change the height. Actually, it kind of bothers me that this isn't relative. So I am going to take this here, copy reference, and say divided by 3 for this one. and times 2/3 here, and then I'm gonna say save no type and match current definition. And when I recook here now, it's gonna always. Oh, I guess I messed that up somehow. Let me see. Yeah, that makes a lot of sense. So, copy parameter, paste relative references, because basically this here it raised the stuff to it, so to make sure it's on the sides. So save no type, match current definition, recook. Ta-da, works. So now I can change the height here, and the fence updates accordingly. So yeah, I hope this gives a bit of an overview of how you can use this already, and maybe gives you some ideas of what you could do with it. Um, if you have any questions, suggestions, anything, feel free to message me. Either write a comment or message me on Twitter, or X, and yeah, I hope you'll get some cool stuff out of this, and yeah, let me know uh, any feedback, anything you'd like to see, and so on. Cheers.